Okay, so last time we talked about using an area model, so where I drew the squares and I found out where the combinations crossed, but that only works if there's two choices. Today we're going to talk about what if there's more choices. So like at Subway, you pick from bread, you pick the type of deli meat you want, you pick like a sauce or an oil, and you can have lettuce and vegetables and all the other stuff and types of cheese. Okay, that doesn't work with an area model, but we can still find how many combinations there are. Okay, so there's something called a tree diagram, and it's used to show all the possible combinations or outcomes. Okay, so let's say you have a red shirt, a hoodie, and a long sleeve shirt. And then for pants, you can choose from jeans or shorts. And for shoes, you have tennis shoes or sandals. Okay, so we're going to make what's called the sample space, and that's just a list of options or combinations. Okay, so step 1, list options for choice 1. Okay, so my first option was the combinations for my shirts. So let's call red shirt R. Let me get my list ready. Okay. Yeah, so I called red shirt R. You'll kind of have to space them out. So this takes practice to space them out well. Okay, you can choose from a hoodie, so I used H, and then long sleeve was L. Okay, then I list my options for choice 2. After I chose a type of shirt, I can choose between 2 different types of pants. So I can choose jeans or I can choose shorts. If I can choose jeans, I can choose shorts. I'll just make this smaller. And if I chose a long sleeve, I can still choose jeans or I can still choose shorts. Okay, and you're gonna do this till there are no more options left. Okay, after I chose pants, I gotta choose an option for my shoes. So I could have chosen tennis shoes or sandals, but here I'm running into the issue where I have S for shorts and S for sandals. So I'm going to do SN for sandals. So I can do tennis shoes or sandals. Tennis shoes or sandals. Tennis shoes or sandals. Tennis shoes or sandals. And tennis shoes or sandals. Okay. So it's called a tree diagram because there's making branches off of each choice for all the other choices. Kind of scoot it up a little bit now. So how many total outfit combinations are there? So we're just going to go through, and these last ones are going to give me however many options there are on the last choice will give me my total combinations. Okay, because here I've done a red shirt, jeans, tennis shoes, a red shirt, jeans, sandals. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 combinations. So what is the probability of choosing red shirt and jeans? Well, I'm going to highlight all the ones that have a red shirt and jeans. Okay. So red shirt, jeans, tennis shoes has that option. Red shirt, jeans, and sandals has that option. So 2, out of 12, or 1/6 of the options are red shirt with jeans. Okay, and then the probability of a hoodie, jeans, or sandals. Okay, here's my hoodie, jeans, and sandals. Well, there's only one of those, so 1 out of 12. Okay? So last but not least, whenever we've been doing these is saying, how many possible combinations are there? And sometimes that's all you need to know, okay? Subway always advertises like, oh, there's like 5,000 different sandwiches you can make, and this is how they do it. Okay, they didn't go through and list all of the options. They did something called the fundamental counting principle. Okay, so let's us find out the possible number of outcomes by taking multiplying the number of choices together. So in this example, you can choose from 3 ice cream flavors, 2 toppings, and then 3 syrup flavors. So I'm going to take my 3 ice cream flavors times my 2 toppings times my 3 syrup flavors. Okay, that gives me 6 times 3, which is 18 possible outcomes. And that's all I have to do for that. So now we're going to practice drawing the tree diagrams, because the best way to really get good at it is really just to do it on your own a bunch of times and make all the combinations.